right, so here is our Python version of this walkthrough, and you can't see any of us on screen, but we're in class right now. Guys, say hi. All right, like you're talking to your future self. Is there anything you want to remember about the past?
I don't know anything right now.
1252, and Will doesn't know anything, but we're going to change that. All right, so we are now going to write Mancala in Python. I have this starter program up here that just has a main method and basically a hello world program, and we're going to start trying to code this in Python, even though I don't know how to code in Python, so it should be fun. I do have our UML diagram that's still relevant. It's the same exact design process. If you want to see how this was made, go check out the other video. But let's write our Mancala program, which is set up for while the game's not over, play around. And actually, why don't we do this as two screens? That way we can kind of jump back and forth. And move that over a little bit. I close that window. There we go. So that's a little bit better. And boom. All right. So we're in the main. If the name is main, instead of saying print hi, let's call play Mancala. All right. And we are going to define the method play Mancala up here. Do you need to send a name? I don't think you need to send a name here, right? That's a parameter that we don't need, so I'm going to take that away. Let's take this comment out. I'm going to put a block comment for this method. Oh, I should also probably spell Mancala correctly. So let's write, I don't know if there's a block comment feature for Python. I think it's all just line comments. So we'll just write this method plays Mancala. All right. And inside our define, we're going to say set up the board. Boom. We are going to say while not game over, which is another method call, colon, because we're in Python, and then play round. I'll put spaces there. All right, now I'm getting an error message. Why am I getting error messages right now? Because, oh my gosh, you guys were kidding me saying you didn't know anything yet. None of these methods are defined. I'm calling a method that does not yet exist. But that's all right, we're doing top-down design. So let's go make those methods exist. I'm going to go up above Mancala. And actually, I want to test something with Python. I think if I define it below, it might not work. Let's try this. Set up board. Set up board, and let's just print in set up. Oh, no, it looks like it worked. So my error message for setup board went away. Let's write another method definition where you're going to define what it means to get game over. Boom. And then we're also going to define what it means to play around. Now in Java, I would have to actually specify a return type. I wonder if PyCharm's going to tell me. Clue. Ignore errors like this for me. I don't know what the error message is, but I assume it has something to do with not returning. So I'm just going to say return false for now. Oh, no semicolon. What's it in Python? Is it capital F false? I told you guys I don't know Python. Still getting an error up there. Unexpected expression syntax. All right. Is this not how you do not in Python? Oh, can you do this? Hey, there we go. Just learned something. So in Python, you don't use an exclamation point to say not. You use literally the word not, and it's a method that just inverts it. So game over is telling me whether or not the game is over. But I want to say while the game is not over, so I use that not there to invert it. Let's get a little block comment for each of these methods. Setup board is going to declare, or I would say initialize. Initialize important game elements to allow the game to be played. All right, for game over, we actually, if we go to our UML diagram, we actually have like a very specific definition for game over because this is probably one of those parts on our tree where it terminates. So I mean, I wonder if I can make this like, I'll put like a special border here. Let's make it like a red border. All right. And that's going to tell me that, hey, I'm not going to go any further breaking down this method. Game over is probably the last method. I'm going to code it. I'm not going to break it down into those 3 or 4 other method calls because it's not necessary. We can just say, what does it mean for the game to be over? Here's the comment that does it. So I'm going to, okay, so it says the game is over. Oh, that's nice. Python put all these, even though I put in a paragraph, I put on different lines. I'm going to shrink this down a little bit so it's not too long. So it says the game is over when either the player side or the computer side has no more stems. There you go. All right. But right now, just to get it to run something, to say the game is never over, return false. I'm in design mode, so we're trying to avoid getting into detailed code right now. Let's see. We did setup board, we did game over, we did play around. Let's see. We need to. Oh, we didn't do play around. So let's do play around now. So play around. What does it mean to play around? This is the execution of one turn in the game, either the computer or player. All right. So that's going to need to alternate between computer and player each time. So let's see. Mancala has setup board, game over, play around. Each of those methods now have a definition. What do you think is the most important method to continue working on? You want to keep working on set the board? All right, so let's go up to set up the board. So in set up board, we said, we need to create the board. We need to fill the board. And I put this initialize players. And actually, what I found when I was doing this in Java is I never actually used this initialize players method. So it's okay if in your design you say, I think I'm going to have to do something, and they find out, it's not necessary. Or maybe it's not necessary yet. Maybe in a later version of the game where I want to keep track of scores and how many credits the player has and their record of wins and losses, then maybe there's some other element. Like imagine logging into an account before you play a game. Maybe there's something like that in the future version. But for this basic version, I'm not worried about it. So I was going to actually delete that since we didn't use it before. But we now need to define these 2 methods, create board and fill board. So let's go and define them. Define, create board. So by default, I will end up always working up the page. So it always keeps my main method at the bottom of the page. That is just a good habit to have your main method in a predictable spot. Some programmers like having their main method always be the first. I prefer to have it always be my last. You don't want it just like kind of mixed around in the middle though. Also, again, we get into class design. We'll talk about where you put accessor and setter methods versus mutator methods versus utility methods. So I might have some functions that provide some service or utility but don't have anything specifically to do with this particular program, and I might want to categorically put them together and separate from methods that are about the game Mancala and are only useful in this program. So a utility method might be something like get input from the user and verify that it is an integer between 2 different numbers. That can be useful in a lot of different programs. It's not unique to Mancala. Dropping the stones, that's a method unique to Mancala. I'm not going to use it anywhere else. So I might separate those. But for now, I'm just working my way up. So not really any rhyme or reason for where I'm putting stuff. Let's see, create board. Creates the data structure to represent the board. And then we're going to have another method, def fill board. And let's say this is going to initialize the board and fill it with appropriate number of stones. So far, so good. Now, again, I do not know much about Python. When we were working in the Java version of this, I decided to use two arrays. One array to represent the player side of the board, another array to represent the computer side of the board. And I started running into issues when thinking about wrapping around and alternating between one array and the other. Because it wasn't so easy to just swap back and forth and keep track of which one I was in. So I started thinking maybe it would be better to have the board represented by one long array, where the front half is the player and the back half is the computer. So I'm only ever going to have one wraparound point. So it makes it a little bit easier to handle that. I'm only ever going to have one reference. Displaying it might be a little bit more of a nuisance, but that's fine. So if we're all right, you guys want to do that? You want to make a single array? All right, so let's think about defining a board. And in Python, I think I'm going to say board equals square brackets.
Yeah.
So now I've made an empty array. And in Python, are arrays dynamic? Meaning, can I make them bigger? I don't know. So let's do a little test. All right. Now what I'm going to do is in play round, I'm going to have a single line of code that's just going to say print the board. And it's going to say unresolved reference board. So board, I can't get to in my play around. I can't see it. This is an issue of what is called scope, meaning that board is defined in this create board method, but down here, I don't know it exists. It's kind of like if I define a word in this room. Hey, everybody, flibble flabble means spatula. Now you all know what flibble flabble is, but the people in the room next door do not. So if it's a reference in there, the scope of that definition doesn't reach them. Now what we could do is make it a global. I think in Python you can actually just write global to define a global variable.
I think you put it in the function.
What do you mean?
So if there is a variable in the program that's not available in the method, I think I'm not sure if you put method in the method.
You put it in the
parentheses in the method.
Well, if I put it in the parentheses, that becomes a parameter. That's something sent to the method. But because I'm not an expert, let's do this. Global variables Python. Sure, let's try this first one. So X is awesome, print X. Now that's defined. Oh, as long as it's defined outside of the function, I guess that's fine. You just define it at the top. Now this is what is called overriding, because I now have two X's and it's going to default to my local version. So it's going to say Python is fantastic in the function and Python is awesome down here. To use the word global, the variable belongs to the global scope. So global X, X is fantastic. Oh, so I would say global board, and then on another line, board equals square brackets.
But you make board now in that method global.
Right.
Yeah, that's when I was saying. I think you put global in the method.
Gotcha. So this line would be the equivalent of doing this. That's how I understand it. Oh, but now it doesn't like that. Because I'm not doing anything with it. So let's just keep it the way, like I'd have to have some kind of line there that I put in, like board equals something. Well, let's just put it back to this. Board is now global, so down here I can print board, and let's just see what happens. Am I getting an error message? I don't think so. Def Mancala, line 18. Indentation error. Expected an indentation block after function definition line 13. Oh, we gotta have something here, I guess, right? So print in fill board. This is a nice troubleshooting technique to use. To just print the name of the method that you're in when you're in it, so that you can kind of see your flow. This is the create board.
Why did you also put that under the creator?
So I'm just going to put it in front of in every method, so that when we are running the game, we can actually kind of see the order in which things get called and the flow of the program. Because it's not going to run top to bottom, right? One method calls another, and which calls another one, and there's loops. So we're going to be kind of going all different methods, and this just makes it a little bit easier to kind of see exactly how it is running. In game over, this is in play round. All right, let's see if that makes everything happy. Still seems like I have an error up there. Oh, there we go. No, it's running. So there's my program. And I got an infinite loop right now because I don't ever actually end the game or nothing really happens, but at least it's running. And I just crashed it. Oh, keyboard interrupt. All right, so the error was I just crashed it on purpose. Still trying to figure out why it's giving me this red line up here. Not sure. Suspend thread. So it's something we might have to look into. All right. So we have an empty board in here. Let's go into filling the board now. And in Python, let's see, Python add to array, because I don't know how to do this. So I know you can define an array as pre-filled. Yeah, so that's pretty common across languages using the brackets. I want to say appending. Oh, so just dot append. All right, so here's what we're going to do. Fill board. Let's define how it's going to be filled. So initializes the board and fills it with the appropriate number of stones. The board will be a single array. The first 6 elements are player pits. Sorry. Followed by player store. Then 6 computer pits and the computer store. Right. So if we want to fill this array up, we could use a for loop, and we'll say for. Oh, in Python, I think I have to use a range, right? So it might be x in range 0, 6, 0, 6. I want to loop 6 times. And we'll do board dot append 4. Oops. Let's see if this works. I just want to see if we can get an array that has 6 fours. I don't know if this works because, again, I'm not an expert. Let's try running it. Hey, look at that. 1, 2, 3, 4, 5, 6. That looks good. And then after that, we want to append a store. So we'll do board dot append 0. And as much as I don't want to do this, we want to do that all again for the computer. So now it should be 6 fours, a 0 for the player, then 6 more fours and a 0 for the computer. Let's see if it works. There we go. Lovely.
I'm still just getting when I write, it's just still printing infill board.
Infill board. All right. Well, did you ever create your board up here?
I did. Wait. I defined fill board before I defined create board.
Okay. Now, something that I think is important. I think if I don't have this line here on line 10, I think if I take this out, I'm going to run into an issue. So let's see. I'm just going to cut it for a second, and let's try running it. Yep. And then I get into an error message because it's saying, hey, you're trying to append to nothingness. So there are two steps happening in the create board. This first step is what's called a declaration. I'll write a comment here. Declaration of the board as global. And this is the initialization of the board as an empty array. So if I'm going to append to something, it implies that I already have something that I can append to. But for that to happen, I've had to have already made this array exist in some way. All right. How do we feel so far?
I'm good. I'm still trying to wrap my head around like initialize. You only use it when you're calling like certain parts.
So think of it this way. If I were to say, I have a friend, Joe. I've declared there is something called Joe that is a friend of mine. Point to Joe.
Oh, wait, I know exactly.
Where's Joe?
Oh, Racky is my friend.
But I just declared this thing. How about I declare Flibble Flubble is something, but you don't know what yet. There's a thing Flibble Flubble I want you to keep track of. I've declared the name Flibble Flubble. I haven't initialized what it is. I could say Flibble Flubble is this coffee mug that I'm pointing to. I know it's not the camera, but I'm pointing to a coffee mug. If I do that, then you go, oh, all right. If I say point to Flibble Flubble, it's coffee mug. Now it's obvious. So initialize is giving an initial value. And in this case, on line 10, I am giving an initial value of an empty array. So I'm telling the computer, hey, board is an array type object. In Java, I would do this. I would say make a global int array called board, and I would declare the type here. But it's not, but I still have to initialize it as an empty array. In Python, because it is dynamic and there's dynamic typing, I'm saying this is an empty array, and I'm giving it the value of make yourself store an empty array for the purpose of letting the board know you're an array type, and I can only append to array types. I can't append to an int or to a character.
Most initializing in the beginning basis, would you say?
Well, usually when you declare a variable, you should initialize right away too. That's a good habit. Doesn't always mean you have to, but it is a very good habit. All right, so right now, if we run our program, this is our Mancala game. Is it super fun? No. Not only that, I also say that it doesn't look like Mancala. So I might go down and say, we really got to change our play round. And let me go back to this UML diagram. The first thing I have in here is a method called display board. And I'm just printing right now, but I'm going to replace this print board with, let's do display board, all right? And then let's define the method display board, def display board. And for right now, we'll do the same thing, print board. And let's say, displays the Mancala board. Now, I just took a line of code out of here, replaced it with a method call, and had that method call that single line. Doesn't that seem like silly, unnecessary work?
No, like it's easier to read when you look at it. Like it's making abstract.
Yeah, I mean, I'm using abstraction. What I'm also doing is I'm giving myself the ability to improve the display of my game without having to edit how I play around. Because now, let's do the rest of our play round design. We're going to say display the board, and then if player turn is true, then do we need a, I think I need parentheses here. So if player turn is true, then is it pay turn, and then else we're going to do C turn for the computer turn. Now I have some error message here. What is player turn? Doesn't know. They go, I need to keep track of whose turn it is. Now I could define that right here. I could say in the first line, player turn is true. It's the player's turn. And that error message goes away. But I'm going to have a problem. Player turn is keeping track of whether or not it's the player's turn. And that should change every single time we run around. One round it's your turn, one round it's my turn. Next round is your turn, then it's my turn. Right? And if I win, if I get it correct, or sorry, if I end my score, I actually get to play again. So it saves my turn. So maybe what I should do is say, I don't want to define this here. Why don't I say when it's time to play the round, player turn will be provided to me. I'll be told whether or not it's the player's turn. So then that kind of puts the, I still got an error though. Oh, because I spelled wrong. So what that does is that ends up putting the scope up a level. So who calls play round? Mancala does. When I say, where's Mancala? I'm actually going to move this down. I like to have my highest level method right above main too, just to kind of keep it same organization. So when I go and say play the round, I'm going to pass player turn, but now that needs to be defined. Well, I can define it here. Player turn equals true. When I first play, the player goes first. And then while the game is not over, play round's the player's turn. But then immediately after that round, as soon as the player's turn is over, what I can do is this. Player turn. Oh, I guess I could do this. Oh my gosh, I can't spell it all. Player turn equals not player turn. So player term is true this round, next time it should be false. If player term is false this turn, next time it could be true. Do you notice, by the way, that my play Mancala method has gotten a bit longer? This always happens. As the program gets more fleshed out, something that started as a teeny tiny method tends to grow. That is why if you are at the early stages of writing a method and it seems like it's a little big, you should have a bias toward breaking it up, because chances are is it's going to increase in size, it's going to increase in complexity. So Mancala is now keeping track of a variable. I might even have that in my UML diagram. Mr. O, do you know where do you write variables in UML diagrams? So you put like a little break in this box. If I'm doing a UML diagram and I'm player, I forget the syntax for it, but I'm just saying, hey, there's a variable called player turn that's going to be defined on this level. So that means scope-wise, I could pass player turn down to any of these three methods, but setup board doesn't need to know. Game over doesn't need to know, but play round does. So I can actually take it and put in here player turn. All right, let's get back to our game. Let's try doing a run, see if it's working. Nope, crashed. Let's see what the problem is. In line 65, line 59, line 49, P turn is not defined. Oh, I never defined these two methods. Let's define those two methods real fast. We got execute player turn. Def P turn. And we'll execute computer's turn, execute the computer's turn. FC turn. All right, so let's see if that took care of those errors and just try running it. There we go. We are running. I'm going to stop it. If we just kind of scroll through our code. Let's see if we can get all the way to the top. Didn't not too many times. Let's see. No, I am in an infinite loop, so boy, it ran it a lot in that amount of time. I guess it's the problem with having to just run with your computer. Well, let's just take any particular place. It says it's in player's turn. Then we check if the game is over, and if it's not, we go to play around. It displays the board. Then it's in computer's turn. We check if the game's over. Then we go to play around. It displays the board. Then it goes to the player's turn. Checks if the game's over. Plays around. You can see the loop in action. Right. What do you guys think at this stage is our biggest problem that needs to be addressed? Is it that the board is not displayed one over the other? Well, it might be nice to actually have the player to try to do something, right? So let's go into the player's turn. And let's think about, oh, I already have it. So what does a player's turn include? Well, first thing, we're going to select a pit. So we're in P turn, and we're going to say select pit. And I think in the last time I wrote the program, I think I did P select pit, because the way that the computer selects, the way that the player selects is very different. So we got P select pit, and then we're going to say P drop stones, and oh, we can write this too. I have if we end in P store. This is a nice little feature here. We're going to call P turn again. So what I just did here is what is called a recursive call. Everybody know what it means to have a recursive call? If you use recursion. Or am I going to guess? Happens again, right? So I'm saying take the player's turn, and when you've finished all the code of this method, the method is done. It's over, right? However, if you end in the player's store, that means the player should take another turn. So rather than go modify this loop up here and say where we're alternating player, computer, player, computer, player, computer, I still want to do that because if the player's turn's not over, after they get to go again, they get a bonus turn. And instead of using like a while loop or a for loop, I'm just saying, well, just start this method over again. Go back to the top of it. So recursion is a very, very powerful tool, especially for solving complex problems. And we'll see it throughout the year.
The P turn and then the player turn.
Oh, all right. So while we do this, I'm going to rename this. How about is player's turn? It's true that it is the player's turn. So it's a good habit when you're naming variables that store a Boolean value, a true-false value, that you name it something that is a true-false statement. So I'd say it is player's turn. It is player's turn. It's true. It's the player's turn. So this is a variable keeping track of whether or not it is the player's turn. Now I got to also do these is player's turn and is player's turn. And then P turn, the method, is actually take the player's turn.
So once it's player's turn.
Right. So one is it Will's turn to play? It's a question, it's either true or false. The next is Will, take your turn.
When I run mine, I'm not getting any errors, just nothing's shown.
Did you ever do your print statements?
Yes. And then print and forward, print and user, print create forward.
Also set up the
Okay.
I never print setup forward.
How about, do you have this? Do you have a main at the bottom that's actually getting called? That's probably a thing.
and that's like the main
Let's basically say, now I know it's a little bit different in Python, but I think if I did this, I'm curious now, if I comment that out and just put this, oops, like that, I think it should still play it. Let's see. Well, now I have other unrelated errors, I think. Oh, I know. Same, play turn. Oh yeah, so this is actually still working. I think this and this, I believe, are equivalent, but again, not a Python expert, so don't quote me on that. This is saying, hey, when you start the program, I'm going to look for something called main. I want to know where your main program starts. So if my program is currently looking for main, then tell it to run this. Versus if I just put play Mancala unindented on the first line, that is the first line of code that I can execute independently. Everything else that is anchored to that unindented first line is just a definition. There's no code to run. Does that make sense?
Yeah, I get that.
All right.
It allows you to kind of put it wherever you want.
I think so. But again, not my most well-known language. I don't want to tell you something that's inaccurate, but that's my assumption.
Because
Right.
I'm thinking, like, from what I know from Java, I feel like you always have to call it right at the start.
Yeah, main's always the first thing that gets done, and that's true most languages. There's some starting point, and there we're saying, hey, here's the starting point. We're being very explicit about
Why would
saying
you not
this.
put this one at the top if you use the Java?
Well, even in Java, I like putting the main at the bottom. But that's my preference. Some programmers like always having it at the top, but I like having the main all the way at the bottom of the program. Just my preference. All right. So let's get these other methods that we just put into our design defined so that we can compile and try running. P select hit, and we'll just say print in P select hit, and let's put a comment here. So this is allows the player to select a pit. So this would be a method where we would not just be selecting the pit, but probably also validating that it is an acceptable pit, meaning the pit they selected is not pit 93, because there is no pit 93, that they didn't write the word cat instead of a number, that the pit they selected actually had stones in it. But right now, I'm not worried about all that. We're not going to get into the weeds yet. I need to do the drop stones. Drops the stones from the pit that the player selected. Def P drop stones. Print in P drop stones. And then end in P store, that's a variable. Right? That's a variable. I'm not sure how to do that yet. So what I'm going to do, just for the sake of not having to worry about it yet, is I'm just going to comment this part out. So it's still there. I'm just acknowledging that I'm not quite sure how I'm going to do that, and I don't want to force something and try to code it. It was more like when I was designing, saying, oh yeah, this is where I would consider this thing. Here's a clever way to put my loop in there, but I'm not ready to code it. So I'm just going to take a step back there and comment it out. Not delete it, but comment it out. Right now, I don't believe we have any errors. So again, let's just try running and see what happens. All right, it's still running on an infinite loop. And part of that is because I don't have a way to pause the program. This is where I want to pause the program. So let's just allow the player to select a pit. Pit equals input, select a pit. Now when we run, it should pause the game. We can actually start from the very beginning and trace the whole run of the program now and see it. The first thing is we say, go into Mancala, then set up a board, then create the board, then fill the board, then check if the game is over, then play around. This is being in the display. Let me put before I forget, where's our display?
Is there a way to, like, display and stop it? That way they can select it after the scene?
I think we did do that, didn't we? So in on display board. So look, all these fours, that is the board being displayed, and that is happening because we hit we call display board. Then we go into the player's turn. Then we go for the player to select a pit. And now I can do it. Now I can actually select pit. I'm going to select pit 3, enter. And then what happened? Let's go back to where we just left off. There's my 3. Then it says player drop stones, check if the game is over, play a new round, display the board. It's the computer's turn. Check if the game is over, play a new round, display a board. It's the player's turn. So the player selects a pit. Select a pit. I'm able to interact with the game a little bit. I want to pause for a moment right here. And I might even stop the video and then start a new one, because I think this is a good place to see why we take this design approach. We can see the whole gameplay. It's not working, it's not doing everything, but it's showing us the structure of the gameplay. Think about that definition of baseball. Right? You assemble 2 teams, until the game's over, you play the game. Well, what does that mean? Well, you're going to play anybody. I could actually walk through, since I know baseball well enough, I could walk through everything that's going to happen in the game kind of generically without the game actually happening. So what we're going to do is you're going to assemble 2 teams. You're going to put the 2 teams on the field. The home team is going to go out into the field. The away team is going to put somebody up at the bat. This is the beginning of the first inning. The pitcher is going to throw the first pitch, or the pitcher is going to pitch until the first person they get the first out. Then the pitcher is going to pitch until they get the second out. Then the pitcher is going to pitch until they get the third out. After the third out, the away team is going to go into the field, and the home team is going to go to the dugout. The home team is going to set their first batter up. The away team's pitcher is going to pitch until they get the first out, then the second out, then the third out. That inning is concluded. Then you start the second inning, and the home team is going to go on the. So I can tell you the whole story. I'm just not into the details yet. But it's a whole lot easier to write the details when I have the whole story out. That kind of makes sense why we take this approach. Now we're also in a good position where we can look at this game and say, what do you think is the biggest problem with this game right now? What would make it a better game to play? What is the most important next thing to do? Have the numbers change. You actually want to drop stones. So let's go to the drop stones method, right? So the player selected a pit. We want to drop stones. What should I do here? Explain to me what it means to drop stones. Think back. You guys have all played Mancala. What does it mean to drop stones?
You pick up, like, say, 4.
All right, so I would say it's going to be
one at a time until you
on pick. I'm going to read these as comments. Pick up stones from the selected pit. Then what?
drop stones until you mark none left.
Drop stones until there are none left.
One at a time.
All right. I'm going to say, I'm going to put the beats here. One at a time in like successive, or in sequence, we'll say, okay. In sequence. And we know more detail about it. We're just trying to get our notes and our thoughts down. So I'm in P drops. I'm only worried about dropping stones. Pick up stones from the selected pit. Which was the selected pit? Well, I don't. Wait, hold on. You don't know anything other than what is defined in P drop stones or global variables. Is the pit that was selected available to you? No, it's out of scope. You go, I need it to be in scope. I need it to be something I can get to. Now, should we make the pit that was selected by the player on this turn a global variable? Probably not. It's not that important of a variable that everybody needs access to it. But maybe what we do is we think about the player's turn and we say, the pit should really be returned from this method and then sent to this method. That's a good way to get this information around. So let me go back up to select the pit. I don't want the pit to be equal to input. I want it to, well, we can do that, but then I'm going to also return the pit. Right. Now when we go into drop stones, I can say I need to get to that particular pit. So we're going to go to board at, that should be pit. I'm going to go to the pit position, and let's just do this. Equals 0. I just want to empty that pit. Let's see if we can do that.
You should add your parentheses.
Thank you, sir. All right. Do I have any errors? Not yet. Watch this. Oh, we're going to end this program because it's currently running. Let's run a new one. Select a pit. Go to select pit 3 and crash.
Many errors.
Many errors. Well, remember, when you see a lot of error messages, it doesn't mean many errors. It means the computer is confused and it's listed many things it's confused about. It could be one error. All right? So we're going to work our way down these lines. It said in Mancala, I called play Mancala, I called play round, I called p turn, I called p drop stones, and in p drop stones, I had a type error. List indices, the index for a list, must be integers or slices, not strings, not strings. It's telling me I tried to give it a string instead of an int, but I typed in the number 3. Here's the issue. When you do input in Python, you are always inputting strings. So I'm putting in the word, the numeral 3. I need to turn it into a number. And I can do that by casting. I can say, I think I just do this. I think I'd say, turn that input into an int. Now let's try running again. Select a pit. I'm going to select pit 3. Let's see what happens. Look at that! We did it! We picked the stones out of the pit. We're making progress. Now, we got more work to do in drop stones. We still have to actually drop them, but isn't this a good place to walk away?
Yeah.
We have a really nice structure.
What percent would you say
I mean, for the B version, 90% of the work. This is the work. You do this part well, everything else is butter. You do this part poorly or not at all, it is mind-numbing to make progress. Because if you have one program that's just 80, 90 lines of code that don't have any structure to it, it's so hard to follow what's going on and to make updates and changes. All right. So we got the structure in place. I'm going to put a pin in this right now, and then what I'll do is maybe I'll make a drop stones method. Actually, maybe drop stones is something we'll talk about tomorrow, but maybe I'll try to make one today if I have a chance.
if we're here tomorrow?
If we're here